start again. Building construction.
Sir, ek minute rukho.
Okay. So you may take a different copy for this one. Building construction. Duta class surveying asile, but I think it will not be a good idea. To first surveying class hoy more. 2 ঘন্টা কাম কৰিব মন নাই আৰু। Can I start, Ravindran?
Yes, sir. Yes, sir.
Yes.
Okay. My screen is visible.
Yes, sir.
Okay. So as I said in your induction class that this subject, building construction and planning, is divided into 2 parts. The first part is building construction and the second part is building planning. So building planning is already it has already been started by Rupjyoti ma'am. So I am starting the building construction part. So building construction. Okay, the first module 1 is about introduction, where we will be learning functional requirements of a building and different types, assam type house, and different classifications as per NBC. So let's start with the first one. Functional requirement of a building. So you may like to write down a few sentences. It is mainly a theoretical subject, so you have to write down along with me. Then only you will be having some kind of class materials for the examination. Okay. So write down functions of buildings and structures. Functions of buildings and structures. So there you write down the function of a building. The function of a building is to provide the desired spatial 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 environment in bracket you write down controlled or uncontrolled within it continuously for a given human activity. Okay. I am going to explain. The building therefore provides a safe and comfortable internal environment against the external the building therefore provides a safe and comfortable internal environment against the external and unwanted internal conditions. The building, next sentence, the building must accomplish these things. The building must accomplish these things economically. Now let's see.
Sir, can you repeat the definition once again?
The function of a building is to provide the desired spatial environment, in bracket controlled and uncontrolled, within it continuously for a given human activity. The building therefore provides a safe and comfortable internal environment against the external and unwanted internal conditions. The building must accomplish these things economically. So if we see this paragraph, so it says that it should provide some kind of environment for a given human activity. So human activity can be of any type. If you see, if you are in your college, that the institutional building, there the human activities are teaching, learning. Then if you are in a laboratory, then carrying out different kind of practicals. So the activity is different. And if you come back home, then your human activity is simply deciding. Okay, it may include sleeping, it may include cooking. Okay, so that kind of it may include any kind of human activity, and against which the building has to provide some kind of desired environment. Okay, desired environment against any kind of external forces, external conditions, you can say external conditions, and unwanted internal conditions. So external conditions may be the rain, okay, snowfall, heat. All right, those unwanted external conditions, we'll see these things in details, but these are some unwanted external conditions for which only you are constructing a building, isn't it? That means if you are inside that building, you are safe from those unwanted external conditions, which may include, as I said, the solar radiation, the heat, okay, the rainfall, snowfall. So maybe anything. Then what is unwanted internal conditions? Internal conditions, what can be unwanted internal conditions? Say a building should be safe in itself for the human activity. Suppose there is a building which is used for laboratory purpose, and in that laboratory, suppose this is the floor, and there is an equipment here. Okay, there is an equipment here, and this equipment is used in such a way that it creates lot of impact on the floor. So this is the first floor. Okay, this is the first floor, this is the ground floor, this is the first floor, and here it is creating a lot of impact. Say one kind of hammer is there. Okay, that hammer is used to break down the aggregates or stones. Okay, break down the aggregates or stones. So it is continuously creating a lots of impact on the floor. So the building should be safe from those kind of internal conditions as well, for the purpose for which the building is created. If it is a library, then it has to carry lots of weight. Okay, you cannot create a residential, you cannot construct a residential building and then convert it to a library, because in library, in one particular rack there will be so many books, and the weight of the books you already know. So will it be same as that of your residential building? No, it is not. So for library, in order to design and construct a library, will have to follow some kind of different loading pattern. So those are internal conditions. Okay, the kind of load you are applying on the building, these are internal conditions. And the external conditions, as I have already mentioned, the solar radiation, the heat, the snowfall, rainfall. So all those things, those are coming from external environment. So the building should provide some kind of desirable environment against this kind of factors. All right. Next, you write down safety in buildings. Wait. The last word. What was the last word? Economically. Economically. That is very important. When you design and construct a building, it has to be economic. Okay. So that's the difference of a modern building and monumental structure. So monumental structure means your say Taj Mahal, then Qutub Minar, all those things. So there the purpose was not to create an environment for living or any kind of your activity of human beings. Those were created just to show off. Okay, so in Taj Mahal, did Shahjahan had to worry about the money? No, it it doesn't. It was not supposed to be economic. Okay, he spent all the money. He could spend all the money to make it a beautiful one. So that's the difference between a monumental structure and a modern building. In modern building, you cannot create that kind of structure without worrying about money. Okay, it has to be economic. So that's why the last term, economically. Then comes your safety in buildings. Safety in buildings. So you write down there, a building should be safe. A building should be safe. The building should be safe against the forces of nature. Against the forces of nature. For example, you write down gravitational load, wind load, earthquake, rain and snowfalls, and also the forces imparted due to human actions. So we have mentioned different kinds of loads. The first one is gravitational load. So the gravitational load comes, although it may come from the objects or the humans which are present inside the building, but also most of the load comes from the structure itself. Okay, this building will be made of some kind of material, say concrete. Okay, it is made of concrete, and concrete is a mixture of aggregate, cement, then fine aggregate, cement, water, isn't it? So you can see how much the load of the structure will be compared to the human beings present inside the building. So suppose there is a person inside the building. At max, how much weight that person will be imparting? Say 100 kg. Okay. If 5 persons are there, 100 kg into 5 at max, then the beds, furniture, all those things are there. Now compared to these things, the dead load, we call it dead load. We'll see in details. We call it dead load of the structure. That means the gravitational load imparted by the structure itself because of the weight of the building will be very high. Okay, the density of concrete is itself it's like 25,000 kg per meter cube. That means if you construct a cube of 1 meter, 1 meter and 1 meter, the total weight of the concrete will be around 25,000 kg. So you can see what will be the self weight of the building itself. So it has to be safe against the self load itself. Then of course wind will be acting on the building, so it will try to vibrate the building. In this manner. Okay, so earthquake may come occasionally. So the building need to save against the earthquake force as well, the rain and snowfalls, and also the forces imparted by the human beings, as I said. So the function, the function is to withstand these loads safely. The function of the building is to withstand these loads safely. All right. So next, you write down interaction of buildings with environment. Interaction of building with environment. So what are the environmental conditions with which the building interacts? We will see. So one by one you write down. There are 9. The first one is called humidity. Second one is called wind. Third one you write down sunlight. Fourth one noise. Fifth, pollution. Sixth, lightning. 7, rainfall or snowfall. Solar radiation. 8 is solar radiation, and 9 is air temperature. Okay, so now if we see this 9 external environmental factors, are all of these like totally undesirable inside the building? Is it so? No. Some are totally undesirable, some are partially desirable. Like, what are the ones which are partially desirable inside the building? Say wind. Okay, if we completely obstruct the entry of wind inside a building, it will be like an oven. So we have to allow some kind of a portion of wind to come inside. So for that we have windows, sunlight. If we completely obstruct sunlight, then it will not be a good idea. And also depending upon different different types of building, that sunlight will be maximized and minimized. So in a residential building, that sunlight will be minimum, but in school and colleges buildings, okay, institutional buildings, the sunlight will be maximized in order to like reduce the electricity bill. Okay, So lots of windows will be there in case of your institutional buildings, and also say in a watch factory. So in a watch factory, you will try to maximize the sunlight, so that the people working inside the watch factory, they can work, because they will be handling minute parts minute parts of a watch, and for that they need good uh, light. Okay, they may need good lighting conditions, so sunlight will be even more maximized in the case of a watch factory. So this is wind and sunlight are not totally undesirable, so the building has to filter the desirable part. So it has to filter the desirable part. It has to filter the desirable part. Noise, is it totally undesirable? What do you say? Noise, if you are, it depends. If you're building, if it is a residential building and it is just by the side of the street, then you may have to totally obstruct the noises, because it will be always noisy because of the vehicular movement on the street. But it should not be totally noise proof as well, because in that case, any kind of external suppose there is a blast nearby, okay, then if the building is totally noise proof, then you will not be even aware that some kind of blast has taken place nearby, some kind of calamities has come. Okay, so maybe 90% of the noise can be cut off and only 10% can be filtered. So the desirable part will be very less in that case. Okay. In case of sunlight, the desirable part depends on the types of the building, as I said. Then pollution. Pollution, of course, you don't want. Okay. So it is totally undesirable inside the building. Lightning, of course, you don't want inside the building. Rainfall and snowfall, of course, you don't want completely. Okay. Solar radiation, you don't want inside the building completely. Then air temperature. So air temperature is again a crucial one. So it need to balance the temperature between the there should not be any kind of temperature gradient. Okay, outside the building and inside the building, there will be, but if the temperature gradient is more, then again one additional problem occurs, that is called condensation. So condensation, what is condensation? Condensation means here when the water particles in gaseous form, they change its form from gaseous to liquid. That is called condensation. So here, suppose cold drinks, you have bought one bottle of cold drinks. So you will see that outside the surface of the bottle, there are some water bubbles. Water bubbles will be formed. Why? Why those water bubbles are formed? It is because of the temperature gradient. Inside the bottle, the material is totally cool, and outside the temperature is more. Okay, so inside, say the temperature is 2 degrees centigrade, outside the temperature is 25 degrees centigrade. So because of this temperature gradient that exists on the surface of the bottle, because of that, some condensation takes place. Now this condensation will be a problem if I construct my building in a cold region. Okay, in a cold region where the outside temperature is say 2 degrees centigrade, and inside you have heater. Okay, inside you have heater and you have made it 25 degrees centigrade. Okay, then the water bubbles will be formed on the inner surface of the building, right? So it will be always damp. Okay, the walls will be always damp on the inner side, and if the outside temperature is say 52 degrees centigrade, and inside you are using AC, okay, to make it say 17 degrees centigrade, then where the water bubbles will be formed, where condensation will take place on the outer surface. Okay, so again it will be damp. So when the walls become damp, it is not a like good healthy condition to live in a damp in a building where damping occurs. There may arise many problems, okay, because of dampness inside the building. Some kind of fungus will be formed on the walls, so ultimately it becomes not worthy of living. Okay, so that's why we need to avoid that kind of problem. So that air temperature is an important one. All right, then next you write down comfortable environment. Comfortable environment. So you write down comfortable environment. Comfortable environment should give comfort against natural external environment, against natural external environment, namely temperature, relative humidity, moisture ingress, condensation, etc. It should be comfortable. Against man-made internal and external agency. Against man-made internal and external agency causing discomfort like noise, microclimatic warmness, etc. Okay. Next, we write down changes caused by human activity. Changes caused by human activity should not affect the comfort. Should not affect the comfort. So here most of the things we have already discussed, like the external factors, temperature, we have already discussed. So during summer, you should not feel the heat so much. Okay, the walls of the building should act some kind of like insulator, okay, to cut off the heat. Then relative humidity, it increases the temperature. Okay, you know that where the places where relative humidity is high, so the temperature, if you see the temperature in your mobile devices, so you see that although it is 25 degrees centigrade air temperature, but it is written it feels like, okay, it feels like say 42 degrees centigrade. What is this? It feels like because in Assam the relative humidity is very high, and because of that, the temperature, even if it is less, you will feel very discomfort. So relative humidity should be cut off inside the building. Then moisture engage. Moisture means mainly the water. So water, what is the source of water that will go inside a building? Mainly rain. Okay, so the rainwater should not go inside the building. Then condensation that we have already learned. Then man-made internal and external agency. So external factors that we learned till now, those nine factors that you have already written, those are the sources of this are is nature, isn't it? The wind, sunlight, noise, pollution, okay, rainfall, solar radiation. Those are formed from nature, but man-made external factors can also be there. So one of them is noise. Okay, noise. If you go to some rural area, that noise you get maybe because of the chirping of the birds or any kind of the wind is blowing. That kind of noise doesn't give you any kind of discomfort. But the noises which are man-made, okay, the horns, mainly these are horns or any kind of say some party is going on, loudspeaker is like some songs are being played on the loudspeaker. So those are man-made noises, and these man-made noises may create some kind of discomfort. And also the microclimatic warm up. So this microclimatic warming is generally because of the concreting of the cities that we see. So generally, if we in an area, suppose this is an area where everything is paved. Okay, everything is paved. Paved means the surface of this area is made of either concrete or may say brick. So everything is paved. No ground is available. Okay, even in a single portion. So everything is paved, and the buildings are made of concrete. So in that case, what will happen? The concrete stores heat. That is like you already might be knowing that. Okay, the concrete buildings, they store heat, and when they store heat, it becomes like even when even during the night, you still feel the heat because that is already being stored by the concrete buildings. And also because of lack of ground, okay, because of lack of ground, what will happen? The generally, suppose this is okay, this is ground and this is concrete surface. So on the ground, if raining occurs, then the rainwater will percolate to the ground, and this particular area will be damp. And after some time, when on the next day, suppose on the next day, it's not a rainy day and sun has appeared, then what will happen? Those water present on this area will evaporate. Okay, so evaporation is a process which automatically cools down the place. Okay, the process of evaporation itself cools down the place. But in case of concrete surface, the water that the rain that hits the surface, that will simply say drained out. Okay, that will simply be drained out and it will go to the drain. So that surfaces are not damp anymore. Okay, those surfaces are not damp anymore. So even it is damp, it is not that much. It's not like the actual soil, which can store lots of water. The concrete cannot store that much of water. So the process of evaporation doesn't happen in case of concrete surface. So as I said, the process of evaporation itself cools down the area. Because of absence of the process, that area will not be cooled down additionally. Okay, so that's why, because of these conditions, this kind of concreting, paving of the ground surfaces, and because of this kind of microclimatic problems will occur. Okay, where you will face some kind of like global warming, where because of the same, suppose this is an urban area and this is a rural area. Here also the temperature goes to 32 degrees centigrade. Here also temperature goes to 32 degrees centigrade. But still you will feel cooler in the rural area because of the absence of this microclimatic warming. Okay, so in urban area you will feel this kind of these are external problems, but these are man-made. Okay, so the heat will be more in case of the urban area. Understood till now? Now we will see different types of load. At the starting only, I have told that the gravitational load in a building plays an important. So this is a building. Okay, so the weight of the building will come into picture. Along with that, the weight of the furnitures, weight of the human beings, that will also come into picture, and also some kind of additional weight. Okay, it may be wind load, it may be earthquake load, it may be load coming from the rain or snow. So these things we need to know. What are the different types of loads and how these loads are classified. Okay. So first one, you write down. Loads are broadly classified into three types. Broadly classified into three types. Number one is steady load. Steady, the name itself suggests that it will be constant. It will be constant throughout. Now, out of these three types of loads, one load, I have not mentioned the names, but briefly I have told you about these three types. So one load will be because of the self weight of the structure. Okay, one type of load will be there because of the presence of the human beings, the furnitures and all. Okay, and one type of load will be there because of the external factors, maybe wind, maybe earthquake or snow or rainfall. Now who will tell me, out of these three types, which one will remain constant throughout the life of the building? Who will tell me?
The load of the building.
Yes, so the self weight of the building, it will be constant. So under steady load, you write down these loads don't change. These loads don't change with respect to time. Okay. They are also known as deterministic or dead load. Okay. So dead load means the weight of the structure, that you remember. You will be using these terms in details in your higher semesters. What is dead load? What is deterministic load? So, but why it is deterministic? Because it is very easy to calculate. Because if you know the dimensions of the different elements of the building, that means if you have walls in a building, then simply you can find out the volume of the brickwork, right? Then you multiply with your density of the bricks, then you will get the weight of the walls. If you have different columns, different beams, then you can find out the dimensions and you can multiply with their densities and you can easily find out their weights. So basically these are deterministic in nature. That means this can be determined very easily, and also these are dead in nature. Dead means they don't change. Okay, they don't change, they remain constant, and that's why these are also called steady load. For example, we have done self weight of the building. Got it? Next type of load you write down quasi steady load. So quasi steady means you write down these loads are deterministic up to some extent. These loads are deterministic up to some extent, but changes with time. Over a long period. Okay, over a long period. Next, write down. They are known as deterministic up to some extent, but changes with time over a long period. They are known as life load or imposed load. Okay. So life load, earlier it was termed as life load. Now this term is not used because it creates some kind of confusion. So it is called imposed load, okay, or IL. So basically these are the loads which are constant for a period of time, but on a longer run it may get changed. Okay. And what will be the example? Who will tell me? Why it is called life or imposed? Because these things, suppose the human beings, the loads being imparted by the human beings on the building, those will be called your life load or imposed load. But the load being imparted by a dead body, will it be dead load or life load? Anyone? Can you tell me? It will be dead load or life load?
Live load.
Because these are changeable. Okay, it's not there in the self weight. It's not integrated with the self weight of the building. So although that is a dead body, but it will create live load. And because of this kind of confusion, so that term live load is not used. It's called imposed load. So not only the loads being exerted by the human beings, but the loads being exerted by the furnitures, machineries is also called your quasi-steady or imposed load. So for example, you write down human beings, then furnitures, machineries. So everything that you keep inside the building, those things are called your imposed load, right? And the number 3 is called dynamic transitory load. Are you ready on? These loads are uncertain in nature. These loads are uncertain in nature, and X for a short period of time. X for a short period of time. Can you give me some example? Anyone?
Wind flow.
External wind load. Very good. The wind load. Then earthquake load. Okay, earthquake load, etc. So the kind of loads that come from the external agencies. Okay. Now if I try to draw one. If I try to draw one graph to represent all this type of loads graphically, then let's change my color. Yes. So if I say here, this is time, this is load. Load means quantity. Okay. Load, the amount of load, say in kilonewton. Okay. So in that case, how my steady load will appear on this graph? How will it appear? With respect to time, it remains constant of the entire building. It is the self weight of the building. So at the initial days after being constructed, if the load is this much, then it will remain constant throughout, isn't it? So steady load will look like this. Agreed? Now, how my quasi-steady load will look like? The loads or the imposed loads, the loads being exerted by the human beings or the furnitures, all those things. So it will remain constant. Okay, it will remain constant up to some time, like that, up to some extent. Then again it may increase. I will explain why it looks like this. Okay. So basically, suppose why it looks like this? Okay, why it looks like this? Quasi-steady. Say one person is coming inside the room, then it is going outside. Inside the building, it is going outside. Inside the building, it is going outside. Then this kind of thing happens on daily basis. So with respect to time, it will always get changed. Okay, little bit. But suppose this depression, it suggests, say during night time, okay, or during say your holidays. Okay, suppose I am drawing this for one institutional building. So during holidays, all the students will go back to their homes. So the load will come down. So again, it will go up. Now, why this sudden jump? Will tell me. Can you tell me why this sudden jump occurs? Suppose the department has decided to replace the furnitures. Okay, earlier they were using some kind of wooden desks and benches. Now the department has decided to replace the wooden desk benches with some kind of, say, steel desk benches. So the load will jump. Okay, the load being imparted will see a sudden jump. So it will jump. Okay. And then even after changing the furnitures, this kind of thing will happen on daily basis. So that's why that things will always be there. Again, suppose the department has decided not to use the room anymore for teaching purpose. So this room is now is always vacant. Okay, the classroom it is no longer a classroom. So again, the load will come down. Understood? বুজি পাইছা এইখিনি? And then the third type. The third type is called dynamic. Yes.
So why it doesn't start from zero? Means the quasi steady load.
Okay, it may start from zero as well, but in a longer run, if you are drawing it for 20 years, okay, if you are showing it for 20 years, it doesn't matter. At the starting of the from day one itself, there will be some furniture on the building, isn't it? It is not
Sir.
always like that. Yeah.
Sir, quasi steady load to sir steady load ke tolot hobo lesi mane hetu to sir negligible hoy na weight to building or weight to not graph.
Okay. So you are telling that this kind of this line should go above this.
Yes.
It is fair enough.
Yes.
It can be like this. I am just showing the pattern. Okay.
Okay.
Because the things cannot be told directly. Okay. In every case, it is not like that. It will be always less. Okay. In some kind of say industrial building. Okay. In some kind of industrial building where huge machineries will be placed inside the building, then it may get increased. It's not a universal truth that the imposed load will be always less than the self weight. But we are concerned about the pattern here. Then the third type is called dynamic transitory. Dynamic transitory load comes for a short period of time. Suppose earthquake comes. Okay, but the load that is imparted due to earthquake is not that small. It may be the highest one. Okay, it may act like this, and it may go back. From zero it starts, and again it may go back to this. From here it may again come. Second earthquake comes. The load is getting applied on a regular basis. So this kind of peaks we will see in case of dynamic transitory load. Okay, this is dynamic transitory load. Are you following? But it will not. Now you have to design our building to withstand this kind of load. Okay, to withstand this kind of load. Now it will not be a good idea to design a building for peak load of every type. Okay, it rarely happens that the raining is occurring, snowfall is occurring, then earthquake also comes of the highest magnitude. Okay, so buildings are like fully occupied at that moment. So it rarely happens that peak of all those kind of loads act together in a building. So we generally go for some combinations. So this is not a part of this subject. You will learn these things in design of structures. So when you will be designing buildings, so there you will be seeing the DL plus IL plus the earthquake load. Okay, so earthquake load, so all those things. So DL plus IL, you may give a factor of safety, say 1.5 times. You need one factor of safety kind of thing. Okay, so what should be the DL of a residential building? What should be the IL of in a residential building or commercial building? These things are already available in your design codes. We'll discuss the names of the codes where you'll get what will be the DL, what will be the IL, what will be the EL acting on a building. So those things in terms of kilonewton per meter is already available in different codes. So basically, if we summarize the loads, coming on a structure may be of the following types of classes. So number 1 we have learned dead load. Number 2 imposed load. Number 3 wind load. Number 4 earthquake load. Then I'm just writing the important ones. Okay. Then snow loads. And number 6 spatial loads. Spatial loads may come into action because of your fire. Say suppose the building is on fire, then some kind of temperature shrinkage will occur. So because of that also an additional load will come into picture. So those things will be covered under your spatial load part. Right? So next we'll learn about your design loads. Design loads. And I will simply mention the different codes where you can find out the dead load amount, imposed load amount, wind load amount, all these things. Okay, so I think I shall stop here. Any doubt? See, I don't prefer generally your presentation. Okay, the presentation teaching I generally don't prefer because the pace of instruction doesn't match with your pace. So I will be explaining the things like this only so that you get a time to write down the things, you get time to understand. So even if you think that this method is not working for you guys, then you let me know. I have to prepare slides and presentations. Can you tell me? Is it okay if I teach like this?
Yes, sir.
Yes.
Yes, sir. It is
Yes,
better.
sir.
All right. So thank you. Okay. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.